Hi. In today's demo, I'm going to walk you through one of the big data offering on Openshift, Oshinko. Oshinko is simply bringing the power of containers to big data. It's a collection of open source projects under Red Analytics community. Red Analytics community is aiming to simplify and empower intelligent application development on Openshift platform. And Oshinko is actually its Apache Spark offering on Openshift. So the main focus of Oshinko is delivering Apache Spark clusters inside Openshift, along with the use of Openshift S2I engine to automate the build and deployment of Apache Spark applications. If we are looking at the different projects under Red Analytics, we can clearly find the Oshinko project here. So Oshinko actually is a collection of projects. One of those projects is the CLI, which is a command line interface. Also, we have the console, which is an extension to Openshift console. We have the web UI. This is the HTML interface, web-based interface that allows you to manage the Spark clusters on Openshift. So how does it work? Oshinko will let you focus on writing your Apache Spark applications. But what about Apache Spark clusters, the master and the worker nodes? How they are actually being created inside Openshift, managed, used, and finally destroyed when we don't need them anymore. Oshinko, through Openshift S2I, provides builder images for Java, Scala, Python, that not only automates the build and deployment of Spark applications, those applications are written in Java or Python or Scala, but also creates the Spark cluster that will be used by those applications. So as you create a new S2I based application on Openshift using Oshinko builder images, Openshift starts the build of the application images and starts the deployment of these images, and finally makes sure there is an Apache cluster running and it is active before launching this application. So first, let's have an overview about Openshift S2I and how does it work, since everything will be done through the S2I build process. I'll just quickly go and Google the Openshift documentation about the source to image. It's an interesting documentation here that describes everything about the S2I engine and how does it work. Briefly, the build process consists of the following three fundamental elements: the source, the S2I scripts, and the builder images. During the build process, S2I must place sources and scripts inside builder image. To do so, S2I creates a tar file that contains sources and scripts, then stream the file into builder images. Before executing the assemble scripts, one of the very important scripts provided within the S2I repository, and then untars that file and places its content into the location specified by the again destination parameter provided to the S2I image. For S2I scripts, you can write them in any programming language as long as the builder image will be able to recognize it and handle it. So back to Oshinko builder image. So what is happening actually? We will use Red Analytics, the Java Spark image, to build our sample Spring Boot Spark application. And as part of the deployment process, Oshinko will look for Spark cluster as provided in the deployment parameter. And if the Spark cluster is not up and running, Oshinko will start a new Spark cluster based on default Spark image, which is provided under Red Analytics Openshift Spark image. You can find it in Docker Hub registry. So once Spark master and worker nodes, either one node or multiple nodes, start and become alive, then the Spring Boot application, which is again bundled in the FATJAR file, will be submitted to Spark master node and Spark cluster to start your Spring Boot application. Simple, isn't it? I think this is the time to start the demo. So all Oshinko projects can be found on GitHub under Red Analytics repository. If you go down and search for Oshinko, we will get all the projects including the CLI, the Web UI, the REST APIs, and also the S2I. If we click on the S2I repository, there you will find the Java builder image, the Scala builder image, and the Python builder image for the S2I engine. So let's quickly start by creating a new project. OC, new project demo. So we have a new project demo created. So it's an empty project. So after creating this project, we will need to again install the Oshinko template. So we can quickly create the template using the OC create command -f https the rad analytics .io /resources.yaml. So this is the Oshinko template. We're going to install this template on the current project. Very good. I think we can quickly look at the output here. So by importing this template, we got actually 1, 2, 3, 4, 5 templates, including the Java Spark build deployment configuration and the Scala deployment configuration, including also the Web UI, whether the again the normal Web UI or the secure Web UI. So if we quickly look at those templates, so the again Oshinko by Spark, this is actually used to create a build configuration. Again, the image stream and deployment configuration using source to image and Python Spark source hosted in Git repository. Looking at Oshinko Java Spark, this is again, this template is used to create build configuration, the image stream, deployment configuration using the S2I engine for any Java Spark application in Git Hub repository. The same for Scala, and as we said for the Oshinko Web UI, this is a web console for Spark cluster management application, including also the Oshinko Web UI secure. So we can actually see the same if we go to the demo project and we click on browse the catalog and search for Oshinko. Perfect. We can see the same here. So this is the Java Spark, the Python Spark, Oshinko Scala Spark, and this is the Web UI and the Web UI secure. So let's create the Web UI. As we said, the Web UI is the web console that will be used to manage the Spark clusters. Through the Oshinko Web UI, we'll be able to create new clusters, we'll be able to scale the Spark cluster, we'll be able also to delete Spark clusters, and we'll be able to access the Spark Web Console from there directly. We can do it directly by, again, selecting the Oshinko Web UI template, or we can switch back to the console, OC console, and just OC new application using Oshinko Web UI. So as we can see, by creating the application, we got the, let's go back to the demo. We got the service. We also got the pod is again starting. Let's quickly look at the logs, what is going on. Okay, so it is getting the default images through the deployment configuration, and here you go. I think now the pod started, and we got the service created, and also we got the route created to be able to access the web console. By clicking on the route URL, it will take us to the Oshinko Web UI. So the first step here is actually to create a Spark cluster. So we need to create a Spark cluster of one master and one worker node. So by clicking deploy, as we can see, we're just giving the Spark cluster name. Let's give it the name test, and here we identify the number of workers. By clicking on deploy, so now what is happening, if we go back to the project where Oshinko Web UI is deployed, we will see two Spark pods are running. For the Spark master, the test -m, and we will see another Spark worker node running as well. So along with the master, we get the Spark Web Console. So if you go back to the master, and this is the route, if we click on the route, this will take us to the Spark master. We can see the same. We close this tab and go back to Oshinko Web UI. We can see that a cluster, a Spark cluster already running, and the number of masters is 1, number of workers is 1, and we can access the Spark UI directly from Oshinko Web UI. Again, through the Spark UI, you will be able to monitor the status of the created Spark cluster directly, as we said, from Oshinko Web UI console, and we will be able to launch the Spark UI. Another interesting feature here, that we will be able to scale the cluster. So by clicking on action and then select scale cluster, here is the number of masters and the number of workers. So let's increase the number of workers to be 2 nodes, and we click scale. If you go back to the project, looking at the number of workers, again immediately we got 2 pods running as Spark worker. So in case we don't need this cluster anymore, as simple as we go back to Oshinko Web UI and click on delete cluster, and then click delete and relax. So if you go back to the project As you can see, both the master pod is terminating as well as the two worker pods are terminating. Let's just wait until Openshift terminates the running pods. So the next step is to look at the Spark application. So we will quickly look at Spring Boot, Java Spring Boot application that again has some logic there using Spark to calculate the value of the buy, the very common buy calculator on Spark. And we will together see how we can take the application directly from Git repository, build the application, deploy it, and create all the required Spark clusters to run the application and get the result. Creating your first Spark application. So now this is the time for creating your first Spark application and deploying it on Openshift. A simple Java application can be found on the following GitHub repository. If you go to the Red Analytics, under tutorial Spark by Java Spring, it's a Spring Boot application used to calculate the value of buy. So this application actually is a simple use case where we use Spark to do a compute intensive tasks. So this application estimates the value of buy. If we navigate through the source code, we go to the Red Analytics package, and then we go to the buy producer. So this is the simple logic for calculating the value of buy, and we do it using again the Java RDD class directly on Spark cluster. So the project classes, there are actually 5 classes can be found on this project. The first one is the Spring Boot application. So this is the main class, and it contains the starting point of your application. The second class is the Spark by controller, and this file contains the code to create the Spring-based HTTP routes and handlers. As you can see, the request mapping here. Then the Spark context provider. And this class mainly contains some helper methods. Those helper methods actually help for creating the connection to Apache Spark cluster, including the configuration and setting the name of the jar file to be submitted to the Spark master. And then the Spark by producer class, which is the Spark based by calculation, the one we've seen. And also we have the Spark by properties, that nothing but actually utility class to load the some properties from the properties file, which is mainly the jar file name. So these are the 5 classes in this project, and as we can see, it's mainly for calculating the value of buy, and this is, as we said, this is one of the very common use cases when it comes to using Spark clusters, what we call the compute intensive tasks. So building the Spark Spring Boot application. In reality, we are not going to do anything. We will leave it to Openshift S2I engine. So we will need just to execute one command in Openshift to be able to create the application, get the source code, build your jar file, which is the Spring Boot fat jar file, and then push the binaries inside the image, and then deploy the image first, start your application before we start the Spring Boot as part of the S2I builder image. There is a small check to be done there. We make sure whether there is an existing Spark cluster or not, and is it actually passed as a parameter so we can use it or not. Otherwise, a new Spark cluster will be provisioned, and then the application will be submitted, this jar file will be submitted to the Spark master to start the calculations. So let's quickly switch to our CLI, so we make sure we are the right project. So this is a project demo. So we will just go ahead and copy the command. So this is a project, the demo project, and it's empty, nothing but Oshinko Web UI. And if we click on the Oshinko Web UI, there is no Spark clusters running. So if we just paste. So this is a command, OC, new application. So we're creating new application, and we are using a template. This template is the Oshinko Java Spark build DC, and this template requires three parameters. Those three parameters are passed to the new application command. The first one actually is the application name as it appears in Openshift and runs in Spark cluster. The second one is the Git repo URL where we have the Spring Boot application source code. And the third one is the jar or the application file or the jar name. This actually jar will be used to package the application and later will be submitted to Spark master for execution. Looking at the logs coming out, okay, the deployment configuration will give us a lot of again details. If we just get the logs, deployment configuration is not yet created because right now the build configuration actually still running. So if we get the build configuration, sorry, OC get build configuration, so there is one build configuration, so OC logs -f this build configuration spark pi. So we can actually follow now the logs coming out of the build process. So what is happening right now, the Java build. So the S2I engine is building the jar file. We can also access the same from the web console. If you go to the web console and click on the build logs, you will be able to get exactly the same logs. So let's wait until the build finishes, so we can follow up from here. Let's see the full log. It's going to take some time because again the Maven build has to download all the dependencies and package the jar file. So these are the list of templates in this project, and we have used this template. So if we have a quick look in this template, so OC export template. So this is a template. Let's export it in YAML format, and export it. Very good. So we got the template. If we open the template, looking at the template, so this is the template. So the first API or the first object in this template is the image stream, and this is the again the image stream after packaging the jar file inside the base image, and this is the build configuration. Okay, so as we can see, this is a build configuration, and these are the parameters we passed through the OCnew app command. So the first one was the application name, okay, and then the git repository, okay, and the app file, which is the jar file. These are the three parameters required for the build configuration. And then we have the deployment configuration. So the deployment configuration, again after we build the image stream, we are going to deploy this image and creating one pod based on this image stream with all those parameters. Some of these parameters are again optional parameters, so if we don't provide them, the default values will be used. And also we can see here the again the triggers. So with every a new image stream, the deployment configuration will be triggered to deploy the newly created image, and we can see the surface to export the again the pods, okay, for internal communication within Openshift. The build is done. Let's quickly go here. Yeah, so now, okay, the S2I engine is pushing all the image layers, as you can see. This is our image. If you go back to the overview, so we are almost done. Very good. So once the image stream is created, so now we can look at the deployment configuration. Very good. See, now this is the interesting thing. So let it finish, and then we'll go back to this first line. If you look at the deployment configuration logs, okay, so look at creating the, again, the ephemeral. First of all, didn't find cluster, okay, so now it's creating the new Spark cluster, okay. So here we figure out that as part of the application deployment, Oshinko is actually starting a new Spark cluster to start the current project, which is the Spring Boot that we just finished the build. So if we go down a little more, okay, the application deployment on Spark, we can see that again starting the application, okay, our jar file, the fat jar file we just built, and package inside the image stream on the Spark cluster. So now let's look at our application and Spark cluster in action. So if you go back to our project, we can see that a new cluster is created, and if you go to the Oshinko, you can simply find the same cluster shown here in Oshinko Web UI. If you click on the Spark UI, so this is our Spark UI that shows how many applications are currently running on Spark cluster, and this is the application ID once it is submitted to Spark cluster, and this is the application name and all the other parameters including the number of cores available to this application. So if we go to the application, and here we just create a route to this application to be able to access it. So there is a route created if I click on this application. So again, this is again Java Spring Boot Spark application. If we add the mapping to this. Let's see what is going on. So that's fine. So pi is roughly 3.1423, and this is the again the logic we've seen inside the pi producer class using the Java RDD class, passing those values to Spark for pi calculations. So if you go back to our Spark, sorry, this is a Spark, okay, and if we look at the worker, so you have this worker, and you can look at the, again, standard logs, and also you can look at the application. So this is the application running there, okay, and have the memory. Look at the standard output for this application. You look at name of the application, and over time this will give you some, again, statistics about the executors and the jobs running on the Spark cluster, okay, and if you click on the job, it takes you to the, again, the class within the application that actually executed this job. And if you click more, again gives you more details about the duration, okay, and GC time, okay, of this job, and you can always access the logs. So this is simply what all you need to run your application, Spark application on Openshift, and to enjoy the Spark features, including, again, creating the cluster, scaling this cluster, or destroying this cluster if it's not required anymore. And this is how easy you can enjoy the big data analytics on Openshift.